ਸਤਿ ਸ਼੍ਰੀ ਅਕਾਲ ਬੈਲ।
Okay, so let's get started with the first question, which is longest subsequence with limited sum. So here we are given two arrays, first one with length n and the second one with length m. So nums is the first array, queries is the second array. Here we are asked to return an array answer, which will also be of the same length as the queries array. So if we take this example, nums is the first array, queries is the second array. Here what we are asked is answer of I is the maximum size of subsequence that you can take from nums such that the sum of its element is less than or equal to queries of I. So if we take this example 4, 5, 2, 1. And the queries are 3, 10, 21. What we have to return is an array of size query where let's take one query at a time. So if we take query of I, let's take I is equal to 0, which is 3. So we have to return the size of maximum numbers we can take from here, from nums. So if our query of I is 3, what is the maximum number of element which we can pick such that it do not exceed 3? 2, right? Because first we'll pick 1. That's the smallest element. We'll be greedy over here. Next, we are going to pick second smallest, that is 2. So here 1 plus 2 is 3. We cannot pick another element, else it will exceed 3. So 2 is the answer over here. Now let's see query of 1. So we have to find number of element whose sum do not exceed 10. So if we have to find the optimal way, like because we know first we are picking the smallest element and then we are picking the second smallest and then we are picking the third smallest, it's better if we sort this array, right? So if we sort it, we get 1, 2, 4 and 5. Now it's easier for us to pick the next element and add it up, and if anywhere we find that the sum is exceeding, we just stop there. So if we have 10, first we'll take 1 plus 2, which is 3, 3 plus 4, which is 7. So far good. 7 plus 5, it is exceeding 10. So we stop over here and return the number of elements which we took. So we cannot take 5. So far we took 3. So we'll just write 3 as the answer for 10. For 21, again we'll repeat the same thing. We start with 1, we take 1, then we take 2. So far 3, 3 plus 4, 7, 7 plus 5, 12, and we don't have any more element. So we took all, and in this case, if we cannot, if our given element is more than the sum of all the elements, our answer will be the size of the array. So here it's 4. This is the brute force way we can solve this question, right? So for each element, we are iterating through our nums array. So if we talk about time complexity of this question, for each query, we are looping through all the elements. So if m is the size of query, n is the size of numbers, at max m times we are looping through n numbers. So m into n will be the time complexity. Is there any way we can reduce this?
First of all, as per these complexity, if we look at the constraints, will this get accepted?
Yeah, so n and m is between 1 to 1000. So if we take the largest value over here, 1000, m is 1000 and n is 1000. So 10 power 3 into 10 power 3, at max it will be 10 power 6 operations we are doing.
Yeah, and one valid point Kumar is adding, we are sorting the array first, so we should add
Yeah, so
n log.
if yes, here it will be n log n. So n log n into m.
No, I think sorting will be a separate operation, right? First we do sorting and then we answer each query. So it will be n log n plus m into n.
Yeah, you are right. So it will be
Yeah, sorting is a
n
sequential operation.
log n plus m into n. So in worst time complexity, we'll take whichever is, more in this.
Yep, so that is still 10 to the power 6.
Yeah.
Yeah. So just a quick poll. How many submitted this problem with brute force? Can you respond in the chat? How many people did it with brute force? Okay, yeah, that was the first question. So basically, easiest approach that beats the constraints, one can implement that. But yeah, we will talk about some optimized approaches also. Yeah, go ahead, Kaushik, please.
Yes. So here we know one thing is like we have to get the sum which is less than equal to the query given to us. So if we somehow form a prefix sum of this array, what we are going to get is 1. 1 plus 2 is 3. 3 plus 4, 7. 7 plus 5, or I'll erase this once. Yeah. So 2, 3, 4, 5. And queries are okay. 4, 5, 2, 1, 3, 10. 4, 5, 2, 1, 3, 10, 21. So this is our query and this is our nums array. Now if we get a prefix sum of this, first we sort it. So we'll get 1, 2, 4 and 5. Then we form a prefix sum. So 1, 1 plus 2 is 3, 3 plus 4, 7, 7 plus 5, 12. Now, if we have this query, it's easy for us to answer. We just have to find an element in this array which will be greater than equal to our query. So if we have 3 over here, if we try to find a number which is greater than 3, like if I ask you which number over here is just greater than 3, answer is 7, right? So what we have to do is 7 is greater than 3. And we cannot take this 7 because 7 is the addition of 4. So we just get -1 and that till there will be our answer.
Yeah, or in a way we can say if we find the index of greater element than 3 and that index is the answer. 7 is at
Yeah,
index 2.
because it is 0-based index, that index itself will become the answer. 0, 1, 2, 3. If we look at 10, so 10 greater than 10 is 12 over here. So 3 is our answer. Now when we look at 21, we don't have the element, so we can take the whole size of the array. So we call this as a upper bound of any number. We are trying to find the upper bound of any number. So upper bound is nothing but a element, the first occurrence of the element which is greater than the element. So if we look for 3, 7 is the first occurrence of the number which is greater than 3. For 10, 12 is the first occurrence of the number. For 21, we don't have. So we can directly take the whole size of the array. And we can implement this upper bound or lower bound with help of binary search. So then our time complexity will reduce to n log n, because first we are sorting the array. Then to search an element, it just take log n time into m operation. So whichever is smaller here. So we from n into m, we reduced it to log n into m plus n log n. And also, like a lot of language all gives us a built-in function to find the upper bound or lower bound. You can go ahead and implement your own as well using binary search. I tried with both the approach which I explained. So this also worked fine. I just found the upper bound of the query of I and subtracted it with the first number. So I got the index, and that was the answer.
Yep, one point about time complexity calculation, Kaushik. First, we are sorting line number 8, it is n log n.
Yes.
Line number 13 is n again.
Yes.
And last is m log n, number of queries log n. So
Yeah, it will be in total n log n plus here n, and then here log n for each. Like this array will run for at max m times, and every time we are doing log n operation. So if we write here, it will be n log n plus n for prefix sum, and then m into log n.
and yeah, and big O wise, if we express it, of course, the most significant term out of these three is, we can say
Either n log n or m log n.
Yeah.
So yeah, this question was because we have a less constraint, we can go ahead and implement a brute force way as well. But if we already know some built-in functions which can give us a better time complexity, it is even easier to write that.
Yep. Any other point anybody wants to add? Any other approach anyone would have taken? Okay, otherwise a quick summary is we can do the brute force, or we can go with prefix sum and then do linear search. And
Yeah.
third is we can do prefix sum and then do binary search.
Yes.
Yep. Okay, we are good to move to next question.